Hello, welcome back. In this lesson, we are going to learn about signal classification. So let's look at the agenda. We will be learning about periodic signal, then aperiodic signal or non-periodic signal, after that deterministic signal, and then random signal. So let's start. What is a periodic signal? A periodic signal is a signal that repeats itself after a definite interval of time. So we can write in mathematical form the periodic signal as xt equal to xt plus t0. And this type of signal is continuous signal when we are plotting it in the time domain. Now xt is a function of time and xt plus t0 is also a function of time, but this t0 is the smallest time interval after which the signal will be repeating itself, and this t0 is known as the periodicity of the signal. Let's understand this with the help of an example. Let's say you are plotting like this. Along this axis we are plotting the time, and along this axis we are plotting the amplitude of the signal xt. So let's say this is a signal under consideration. So you see, the signal is repeating itself after a definite interval of time. If you consider it to be -1 plus 1, so this will be of periodicity. So this is minus t by 2 to plus t by 2. And from here to here, this is the periodicity of the signal. So what is the periodicity of the signal? Periodicity of the signal in this case is, it is 2. So again from here it will be plus 3 and it will be minus 2. So we can see that this is the portion of the signal that is getting repeated after an interval of 2. So from -1 to +1 through 0. Again from +1 to +3, you see the nature of the signal is same, so it is getting repeated. So here t0 is equal to 2. So this is known as the periodic signal. Now this was for continuous. For discrete signal, we can write xn equal to xn plus n, where n is the sampling instant. So number of samples we are taking. So a discrete signal is represented like this. So the sample values will be taken like this. So you will see the signal will be repeating itself. Again you see it starts. So from here to here, the signal has repeated itself. Again it is starting. So this is an example of discrete periodic signal. Now let's understand whether the signal is periodic or non-periodic with the help of two examples. Now let's understand it with example 1. It is written here xn equal to sine n by 2 plus minus phi. Now this phi is the phase of the signal. Now one point to be remembered here is this. As we said, t0 is the fundamental periodicity, or it is also known as the time period. F is the fundamental frequency, and f is given as, it is basically the linear frequency. F is given as 2 pi omega, where omega is the angular frequency. One thing we must remember here, f is known as the fundamental frequency and this is the linear frequency. We also have another frequency omega, which is the angular frequency, and it is given as 2 pi f. Now T is T naught equal to 1 by f. So this is the relation. Now one necessary condition for a signal to be periodic in nature is omega by 2 pi should be a rational number, m by n, where m is the number of full cycles and n is the number of samples. Now let us come to this equation, xn equal to sine n by 2 plus minus phi. So how to check whether this signal is periodic or not? You have to check it with sine omega n plus minus phi. Now here omega n is equal to n by 2. So you cancel n, which leads to omega is equal to 1 by 2. Now you have to check this point. So omega by 2 pi will be equal to 1 by 2 into 1 by 2 pi. So it is going to be 1 by 4 pi. Now this is not a rational number. So this is not a periodic signal. Let's check another example. So this is another example, xn equal to exponential j pi n by 2. You have to compare with exponential j omega n. So here jj gets cancelled and we are left with omega n equal to pi n by 2. Again n gets cancelled. So omega by pi becomes 1 by 2 and this 1 by 2 is a rational number. So this example shows that xn is periodic in nature. Now what is an aperiodic signal? An aperiodic signal is a signal which does not repeat itself after definite interval of time, or an aperiodic signal does not have any periodicity. For example, if we draw like this is an example of aperiodic signal. Another example we can draw. This is also an example of aperiodic signal. This aperiodic signal is not repeating itself after definite interval of time. Now what is a deterministic signal? A deterministic signal is a signal which can be represented by a mathematical expression. For example, we can draw here 3 examples of deterministic signal: x1t, x2t and x3t. So if we draw it like this, so this signal is a cos signal. So this is a deterministic signal. It can be represented by a mathematical equation. Another signal, this is another signal which is a deterministic signal. x2t is basically ut, or this is called a unit step function. Another signal we can have as a deterministic signal. So this is also a deterministic signal. x3t can be written in mathematical form as e to the power minus t. So these are all as deterministic signals. A random signal is one which cannot be determined by any mathematical expression. For example of random signal is noise signal. So if you plot noise, it will be somewhat like this. It will have no periodicity, and it cannot also be expressed with the help of any mathematical expression. So this is a random signal. To summarize, in this lesson, we have learned about classification of signals. We have learned about periodic signal, and we learned how to check whether a signal is periodic or not. We have learned about aperiodic signal, and we learned about deterministic signal, and lastly we learned about the random signal. Thank you.